Hello all, we're going to go ahead and take a look at this integral. We need to do partial fractions in order to deal with this integral. So let's go ahead and take a look. First of all, we'd like to write this integral with a factor denominator. It's going to help us figure out what the partial fractions process should be. So we're going to write the denominator as x times x squared plus 1. So since the denominator can be broken up into two factors like this, and one is a quadratic, one is just a linear factor, we know that this 7x squared plus x plus 3 all over x times x squared plus 1, we know all of this is going to be equal to some linear factor all over x squared plus 1 plus some constant over x. This is the partial fractions decomposition of this particular rational function. So we just have to decide what a, b, and c need to be. Easiest thing to do here is to multiply on both sides by both x and x squared plus 1. And so all of these denominators are going to go away. When we do this, we're going to get ax plus b times x on this side, and then plus c times x squared plus 1. Okay, well, not a problem. We'll just continue. So this becomes ax squared plus bx plus cx squared plus c. And we're just going to group all of the x squareds, all of the x's, and all of the 1's. So this is a plus c x squared plus bx plus c. Now we know that the number of x squareds on both sides of equal sign has to be 7. So we have this linear system now. We have a plus c is going to be equal to 7. We know that the number of x's have to be 1, and so we know that b has to be equal to 1. And we know that the number of 1's has to be 3, and over here the number of 1's is also c. So what we do is we just pair the number of 1's, the number of x's, and the number of x squareds on both sides of this equal sign. And if this is true, if c is really 3 and b is really 1, then that means a must have been 4, right? So now that we know all of this, we can just put 4, 1, and 3 in up here for our numerators, and this integral that we had a lot of difficulty with before, this very unpleasant looking integral, has turned into the integral of 4x plus 1 all over x squared plus 1, and then plus 3 all over x. Now, we know what to do with the 3 over x, but this 4x plus 1 is still a problem in the numerator here. So we have to do something at least a little bit sneaky. What we're going to do is we're going to split up the fractions. So we have 4x all over x squared plus 1. We have 1 all over x squared plus 1. And we have this 3 over x. And from here, it's going to be a lot simpler process. This integral of 4x all over x squared plus 1, this is a problem that you can solve using u substitution. If you feel comfortable doing these in your head, fine. If not, that's okay. Just do it however you feel most comfortable doing it. But you're going to end up getting 2 natural log of absolute value of x squared plus 1 when you're done. Right? Next up, people will recognize that this is the derivative of arctangent, and so this is a very easy antiderivative for us to get. And then the antiderivative of 3 over x is just going to be 3 times natural log of absolute value of x. So there's a little bit of a u substitution here. I skipped that in this particular problem. If you want to know how this is done, feel free to contact me in my office or in class. I'll be happy to explain it. Otherwise, I hope this has been a fairly helpful thing. If you have any questions, just stop by. Anyway, good luck and happy mathing.